Good afternoon, everyone. Thank you for the opportunity to come and present today. It's actually not very often that I'm allowed out, so it's quite nice to just come along and just give an introduction into intelligent infrastructure, and then I'll hand over to Paul, who will go more around into the Insight tool. So, Network Rail Intelligent Infrastructure Programme, it's a digital programme. It's all around enabling our data within Network Rail. As many people will know in here, Network Rail, I would say, is drowning in data and has been for years, and it's about what we do with that data going forward in the future and making better informed decisions with the use of that data. We're a control period programme, and we are about to go into that last year. So we have got a very, very busy year to complete all the work that we agreed we would do with the government at the beginning of that control period. I am pleased to say, though, and I'll come on to it in one of my slides very shortly, is that we've done a huge amount of work. There have been a number of challenges over the last 4 years, and I will touch on that because I think other people in the other presentations have also mentioned that in terms of what those challenges are in getting technology out. But in terms of the Insight tool that Paul will be speaking about, it's brilliant that, one, we've got the tool and it's out there, but it's actually got a roadmap into CP7 as well, and again, I'll touch on that in a moment. All the tools within intelligent infrastructure are all web-based, so they're all in the Azure cloud, and the strategy around that was towards to enable all the data transfer. So as I said right at the beginning, we've got huge amounts of data across Network Rail, and being able to bring them into the Azure Data Mart area has allowed us to really manipulate that and really support the customers, which is our regions, our routes, our contractors, in terms of using those tools to make better informed decisions. If I move on. Links with the industry. People have said this already, and if I was to really focus on two areas. The importance of intelligent infrastructure and what we are trying to achieve for Network Rail. The first thing is improving safety. So the Insight Predict and Prevent tool is enabling the customers, the users of the system, to predict what's going to happen or out on track, and therefore, again, the term that everyone's used already is around boots on ballast. But it's more for me in terms of we're improving that element of it, and that will filter down into the passengers. And we've got to be putting the passengers first, making a more reliable service and better value for the end passengers. And I think we're all in this room would be on the same page in terms of where we're trying to drive to make that happen. In terms of what the number of projects across II and what we're trying to achieve and what we've got left in this next year, I think it would be an understatement to say what we agreed to do at the beginning of the control period was mammoth. And then during that period, we've had COVID, which basically meant we offshored the majority of our resource, of our SI partners, our system integrator partners, which brought its own challenges. In terms of Network Rail staff on the Intelligent Infrastructure Programme, there's 32 people delivering all of this. The rest was around utilising our partners. And then over that period and the challenges that COVID brings, obviously all our regions and routes have got competing and conflicting priorities to deliver. So when you start rolling out some of these applications, and I'll touch on a few in a moment, it's very challenging in a devolved organisation to get them to take the solution straight away. And then thirdly, as I said towards the end, we've got a huge amount coming up as well to deliver now. And again, that's down to the competing elements of the regions and routes. It's down to COVID. It's also down to us making mistakes along the way. So I don't think any technology company would say they've got it right first time. And then our other biggest challenge within intelligent infrastructure, the majority of all our systems are for our key workforce, which means we have to involve our unions. And the environment we're all working in the moment in Network Rail, it is extremely challenging to be able to have the time to talk around releasing technology into the workforce. But as I said, Paul's just about to touch on Insight. And that's a project that we started obviously 4 years ago, and it really came into fruition over these last 2 years. And this is all around us being able to do the predict and prevent of our track and our signalling equipment and allowing our end users to make more informed decisions. But the other key element to intelligent infrastructure is then being able to start to integrate a lot of these products together to make the whole planning process and work process more fluid and end-to-end to add to the value for the customers. So with that, I will hand over to Paul, who will go more into the Insight product.
Thanks. Okay, good afternoon. So I know a number of you saw an initial presentation on Insight that we did in Birmingham last year, and the main focus for today is to show you how it's moved on from there. As I say, Stephen said, we've done a lot of work over the last 12 months, an incredible amount of work to get where we are today. We've still got a lot to do in the next 12 months, and everybody thought a few years ago, oh, end of control period's miles away. It's amazing how quickly it comes around. So what is Insight? Insight is a tool that we've developed along with our end users. So one of the major changes we put into place when we went into this control period, and one of the criticisms we've had of many Network Rail programs in the past is somebody in the centre thinks it's a wonderful idea and pushes it out to the routes and says, you will use this tool. And the routes go, well, what you've delivered is not what we asked for. Or we take the requirements and then deliver something different. That's the major change we made with this program. So this program is built from the bottom up. The people who are going to use this tool on a day-to-day basis. And the idea of this is it's a decision support tool. It's not there to tell engineers how to do their job. It's there to help them make more informed decisions. As Stephen says, Network Rail swamps in data. What it doesn't have a lot of times is intelligence around that data. And that's what we've tried to do with this. We're trying to turn data into intelligence. The thing we were told at the start is, do not just throw us more data because we can't cope with it. Give us some intelligence. And that's what we've done with this program. So we've taken data predominantly from our measurement train fleet, although we are looking over time to introduce data from service trains as well. And we take all that data, we run it through various algorithms and alignment processes to align all the data so that we know we're always looking in the same place every time when we review the data. And then we present that data, anything up to predicting anything up to 365 days in advance, with around 75% confidence rating that that prediction is going to come true. With certain other factors like cyclic top, we have a 90% confidence factor, but we predict over a much shorter period. With signalling assets, we're looking 7 days in advance. That's how accurate some of our machine learning is. So it can start to spot anomalies in POE equipment and things like that, point operating equipment, earlier on in the process. So rather than waiting for something to go wrong, we're trying to predict these things in advance. And that's what the whole essence of Insight is about, and intelligent infrastructure, is getting us away from a reactive world where a fault happens and we've got 14 days to fix it. If we know it's going to happen up to a year in advance, sometimes it's not always a year, we've got more time to plan. We've also got more time to do the optimal fix. So rather than going in and having 14 days and limited access to go and do something, we can plan a lot further out to do the optimal fix, which often means that we only have to go in once and do the correction. We don't have to go in late, do a less than optimal fix, obviously a safe fix, but that fault repeats again time and time again, causing more disruption for passengers. And that's the whole point of what we're trying to do as well. So say Insight is a web-based tool, so it's accessible to end users on a desktop, laptop. It works on an iPad, it'll even work on a phone. I've been on my phone with it this morning doing various bits and pieces for end users. Resolution's a bit small on a phone, so we try and use it on iPads. But what it does is it takes away pieces of paper. It means that engineers can take historic information up to 14, 15 months old with them when they go to site, and allow them to look at traces and look at how an asset is degrading over time, and also highlight to them things that may not be possible to spot with the naked eye, but is in the data we use. So it's a decision support tool. It's not there to tell an engineer how to do his or her job. That was made very clear to us as well. That's not what they wanted. And as Stephen said, we've not finished yet. We've got a lot more to come. We're just about to release a new piece of functionality around risk-based maintenance for track. We've got signalling innovations coming through. We're working with EMP teams as well to try and get some of their data into the tool. So there's a lot more still to come. We've got rail management. We've got all sorts of things to do. Some of it will be delivered by the end of CP6, but as Steve says, a lot of it will roll over into CP7 as well. So what is Insight for track? So, as I said earlier, the whole idea of Insight is to try and move up the P2F curve. So we don't want to be reacting things when we get to intervention limits, which means we've got 14, 28 days to go and do something, depending what the defect is. We're trying to get up to anything up to a year and even another 3 months ahead of that. So we've got predictive capability in the tool which says we can predict up to 90 days of something becoming an alert limit fault, a level 1 fault, and then project out, if that fault's left in the track, what's it going to do over time? The idea is as well is we can start to map where interventions are needed together. So to do that optimal fix, so rather than treating individual little defects, we can start to group defects so we can maximise possession and access opportunities, which are becoming more and more limited on the railway. But again, it means we then only have to send people out once to treat a number of things in a location, rather than have to send them out lots of different times. Again, keeping boots off ballast. So, for an engineer to do what is shown in the top right chart means they've got to literally take 12 pieces of paper with traces on and either use tracing paper to look previously what's happened to try and see any movement, or in some cases hold these pieces of paper up to a light or a window to try and see through them to understand. And we're talking about millimetre changes in trace values in some of these cases. What we've done is we've taken that data that comes from our measurement train fleet, we've aligned it using an algorithm, as I say, so we know we're always looking in the same place in the track every time, and we've overlaid up to 12 traces of data. That goes potentially going back around 450 days. We then turn that on its side and we then predict, based using linear regression, because that's the tool that we found gave us the most accurate results. And we start to predict forward that based on the rate of degradation at the moment, if nothing else changes, that rate of degradation carries on linear, and then that's the point it will then pass through future thresholds. So we're trying to get that in advance. Across on the right-hand side, you've got cyclic top. For the first time, engineers are now being given predictions of cyclic top. So rather than suddenly being surprised by it when the measurement train run, we've now got a patented process which allows us to predict cyclic top, as I say, with around a 90% accuracy of the time it's going to take to progress to a defect and the level it's going to predict at. And it's not just on one frequency or wavelength, it's across multiple wavelengths. And as you can see there, that's how it gets mapped to the engineers. Before, they had to request this, and it meant somebody in my team had to create an Excel spreadsheet to send them this data out. Now it's all sent automatically to them. PLPR, so plain line pattern recognition, we take the images from the measurement trains as well that are produced to identify defects in the track. And normally these are sent out just as little thumbnails on a PDF. We've now got the ability to manipulate those images in a lot greater detail. So they can zoom right into the image, even down to looking at a clip housing to understand what's happening in that location. It, again, saves them having to go out. They can now do a lot more from their desktop rather than having to go out to verify what the PLPR train is telling them. We also now cut out the number of repeat defects that appear that are actually not repeat defects. It's the same defect, but because of the variability on the drift on the measurement system, the train is not always recording in exactly the same place every time. What we've done is taken that out. So we've removed about 40 to 50% of repeat defects. Therefore means the engineer has less things to review each time they do their review, therefore giving them a big time saving when they're conducting their reviews. And you can see here, we can zoom right in to start. So that's the image if they looked on the screen full size on the left, and on the right, this shows them the ability to drill right down into the image so they can start to see in close detail what's happening with that piece of track. And clearly you can see here on the running band there's quite a bit of damage. But again, now don't need to send an engineer out to go and verify that off the train. I can now identify that and then start to plan some work to do something about it. The Insight Track Vision, so the direction from our chief engineer is Insight will be the tool for all management of rail defects going forward. and also on signalling. So everything that we're collecting, all the different data that we've got in multiple different systems, and to even do a track review, an engineer potentially has to have 3 or 4 screens open at the moment trying to do that review, because they've got to have a screen open for Ellipse, they've got to have a screen open for Inham. If they've got RBM, they've got to have a piece of paper which shows them what their RBM regime is. All this in one current multiple systems, we're trying to get all that into one system. We will have then all the data from Ellipse, and then eventually when we get to later on this year, the end of summer, the ability will be to be able to create a work order in Ellipse directly from our tool. And the tool, the way the tool captures the data and creates the defect with much more discrete mileages for that defect means that level of data quality improves within Ellipse, because the information is coming straight from this tool rather than somebody putting something in, or in a lot of cases forgetting to put something in, which means we don't get the right level of accuracy of data in our Ellipse system. We're looking, as we say, to take data. We do take data from our measurement train fleet. We're working very closely with Balfours and Hitachi on getting data in from service trains as well. So from East Coast Main Line, from TransPennine Express, and from Western Main Line. We are very, very close within a few weeks of now getting that data into the tool as well, and being able to use that data to supplement what our measurement fleet is doing. So if our measurement fleet doesn't record on a regular basis, we've got a backup system as well. But it also allows other areas of the industry of the network to manage their defects in a slightly different way. So instead of having to wait 4 weeks for a defect that's been rectified to be verified, it's clear, we can start to use the measurement, the service train data to take those speed restrictions off quicker. RBM regime, that's the next big tool. That's just gone live in a couple of areas and will be rolled out nationally from the end of March. And this allows individual routes, regions to put their own RBM regimes into the tool, risk-based maintenance. So rather than reacting to the national standards, it'll react to local regimes. And again, they can then tailor those regimes to understand where they are in reacting to defects. So for instance, some areas now say, well, we're perfectly happy, we're managing at level 1. We're going to set ourselves a challenge to manage even below level 1 defects. So they want to start doing that and getting earlier notification of defects. So these are just some sound bites from what people have said about the tool. We've got a moment around 1,200 users of the tool rolled out across the country. More joining as we put new functionality in and we increase the scope of the roles that are needed to use the tool. Just this week, I've been speaking to an engineer who said using the tool now has saved them. Normally it took them 2 weeks to do their OTM plan, on-track machine plan for the year. They now did it in 2 days. They now can have a more focused plan because they know exactly, based on the data within the tool, where to put their machines. So rather than just spreading them out or using the machines as and where they can, this is now giving them a more tailored plan. We stopped a speed going on the West Coast Main Line last week, which would have, if it had gone on, based on historic information, would have cost Network Rail over £250,000 and also meant a massive inconvenience in delay minutes to passengers using West Coast Main Line. We stopped that going on because the engineer could recognise the cyclic top was building and therefore could go and do something about it before it came off the measurement train. That's the sort of thing we're trying to do with the tool. So that's the end of our presentation and what Insight is delivering. As I say, over the next 12 months, there's a lot more to go into it, and hopefully we can get an opportunity to come back on a future event and show you when we get the next lots of functionality. In the meantime, thank you for your time.